Hi, I'm Dr. Levi.
And I'm Dr. Bellinger.
And we're here to talk to you about the classifications of matter.
In our matter video project. Enjoy.
First, let's start with the substances. We have an element and we have a compound. An element is one type of atom, whereas a compound is more than one. So, let's say oxygen or gold. Those would be an element. But then once you combine two together, they become a compound. So, two hydrogens and one oxygen would be a compound, which is water.
Let's move on to mixtures. There's a homogeneous mixture and a heterogeneous mixture. A homogeneous mixture means that everything is mixed well together and infused well together. Like this Kool-Aid I have over here. Perfect. And a heterogeneous mixture is a mixture that is not well fused
And now
together.
back to substances. So keep in mind that an element is one type of atom. So this could be an element, or this could be an element. See, even these two together would still be elements. But then once you mix two different ones together, like this, they become a compound. So this is a compound. Or these two would be a compound. Even these two are a compound.
An example of a homogeneous mixture would be Kool-Aid mixing into water, like this. Now you stir it up a little bit, and it is perfectly uniformly mixed. You can even add the red Kool-Aid in there, and you still get it perfectly mixed in. Mix it up a little bit. It's perfectly mixed. A heterogeneous mixture would be syrup into water. See how it does not mix? Even if I take a mixing tool, mix it up a little bit, still stays at the bottom. This means that it does not perfectly mix, and I'll even put a tomato into the earlier experiment. Notice how it floats to the bottom, does not separate. It's a heterogeneous mixture.
Particle level model. This would be an element. Even this would be an element. Now for a compound. This is an example of a compound right here. So is this. And then for a mixture would be when you throw different pieces into it. So a mixture is all of them together.
To states of matter. First off, we'll start with the liquid. See, the atoms in this are free-flowing and can move side to side, and they conform to their container. So if I were to spill this on the table, it would disperse all over. Gas takes the shape and volume of its container, just like the oxygen in this room.
Now on to examples. Let's first start off with liquid. One can tell how it doesn't have a set shape, but it does have a set volume. My first example is water. Another example would be the syrup that we used earlier. And a third example would be some of this grape Kool-Aid. An example of a solid could be ice. Another example could be this rock, which in this case happens to be a crystal. Or we can go back to the basics, and it can be an apple. Gases. First, let's start with the gas form of water. Steam. Now on to smoke. Alright, now if you look closely to see it, you can see the smoke coming off it, which is another gas form. And our third example for gas is this beach ball, which I'm going to blow CO2 into, which shows how it fills to the size of its container. Particle level model that shows the arrangement of the particles. First, let's start with solid. So in a solid, all the particles stay packed together, but they vibrate slowly around. Now for liquid. In a liquid, they're free-flowing and able to go past each other. And for a gas, they shake violently and are spread out.